And very good morning to the webinar attendees. My name is Rumyantseva, and today I'm presenting with Mehmet Şükrü. And the title of our talk is MLOps Framework in Pentaho, Workflow Orchestration and Automation. So I'm going to start with a description of MLOps and how it can be implemented in Pentaho. And then Mehmet will follow up with Tüpraş use case and how they used the platform for their analytical needs and machine learning. So the original MLOps framework takes its origin from a CRISP-DM methodology that stands for Cross-Industry Standard Process for Data Mining. This methodology was established in 1996 by the pioneers of immature at that time data mining market. At that time, companies that were establishing data science, data mining practice were dealing with a much smaller amounts of data, and also the number of use cases was smaller. But they managed to build this robust methodology that is still widely used by many organizations. This methodology has the 6 main steps. First, we start with business understanding, so defining the use case that we want to address with the data mining techniques. Then we understand the data that we have related to this use case. Then we step into data preparation, modeling, evaluation, and deployment. As we moved on and we started working with a high amount of data, we started building more models. We needed to extend this framework with operationalization cycle. So what do we mean by that? If we build a model and deploy it in production, there may be lots of changes that can affect the model performance and its ability to address business needs. We're dealing with the higher volumes of data, and we need to see if there is any drifts in this in the data and change in the conditions. We need to deal with constantly changing business requirements, software, and another important point that machine learning techniques and deep learning techniques are constantly evolving. So if we take on board new technologies and new techniques in the field of machine learning and data science, we need to test if our original model deployed in the production is still best performing one. So therefore, we need to extend the original CRISP-DM framework with operationalization cycle, where we monitor models in production and quickly get alerts if there are any changes. Before I jump into components of implementation of MLOps in Pentaho, I want to give a quick overview of what Pentaho data integration is. Pentaho data integration is a platform for data engineering and orchestration. It allows to ingest data from multiple sources. It's structured, semi-structured, and structured data. It represents drag and drop interface. It's technology agnostic. It allows you to graphically build workflows for data preparation. It also has the ability to connect you to line of business applications and dashboards. You can process batch and streaming data, and it's user-friendly, and you can incorporate your models written in variety of languages into the workflow, therefore building this machine learning orchestration framework. And on the next slide, we can see the high level of implementation of MLOps in Pentaho. What you can see is Pentaho workflow that consists of several jobs. So there are 2 levels of operation with data in Pentaho. It's Pentaho transformations and Pentaho jobs. The transformation operate with data on a tabular basis, and Pentaho jobs is a more high-level workflow orchestration. And you can see that we can attach multiple modules. And here we have model related to data preparation, checking for data drift, application of model, checking model drift, model deployment, building new model, and discovering new data. Now let's discuss some of these components in a bit more detail. The first thing that you do is you build a workflow for data preparation, and once your data in the right format that you need, you want to do exploratory analysis and model development. In Pentaho, we have capabilities for integration with environments such as Jupyter Notebook through the data services and performing automatic exploratory data analysis by leveraging some of the open source packages. In the Jupyter Notebook, you can also utilize open source frameworks such as MLflow to have a consistency in terms of your model experiments, saving the models, and building the models in the right form that they can be further operationalized in Pentaho. The next important step is automate workflows for the champion and challenger tests. Let's say we develop several models and we want to make sure that automatically we push the best performing model into production. As we get more data, the best performing model might not be the champion anymore. It might be the second best performing model from the previous iteration of the experiment. So we define the champion model as the original best performing model that we deployed into production, and the challenger models are the new variation or retrained model. And on the next slide, you can see the transformation for test. So what we do, we load up the new test data set, we score the models, our champion and the challenger. And on this transformation, you can see only one champion and one challenger, but in reality, you can attach as many challenger models as you want. We evaluate metrics of model performance, then we do comparison, and in case one of the challengers beats the champion, we swap the model that is in production. And automation of this workflow is highly performant, is highly important, and for model monitoring and getting to know what sort of changes are happening as you get more data. Another important step in MLO frameworks is parameter testing. So what do we mean with parameter testing? When we develop the models and when we do data preparation, we get to the certain set of features that have the certain shape. And we also have the data preparation workflow that's built for the certain number of columns, types of columns, and column names. If we get more data sets and we have the new data streams coming constantly, we need to make sure that the format of the new data is consistent to the one that we have workflows developed for. Therefore, we build the workflow for parameter testing, and if there are any alterations in the shape or types of data coming from the source, we can alert the engineering or IT team to adjust accordingly our data preparation workflows and make sure that we have consistency what goes into the model. Another important component in MLOps framework is checking for data and model drifts. So in our model, they say, we consider here a supervised learning algorithms. We have the set of input features and we have the set of target features. And in case there are any statistical drifts in the input features or in the target features, we want to be aware of that. That means that in the original data, in the data that we are getting, there is a certain regime shift and our model might start deteriorate. Our input features and target features can be of two formats. We can have categorical values or continuous values. And we need to orchestrate two types of drift detection techniques, such as early drift detection for categorical variables that can be one-hot encoded, or adaptive windowing for continuous features. And in case we have data or model drifts, we can get alerts. Therefore, in Pentaho, we can simplify and automate multiple components of the modern MLOps framework. It's efficient data preparation, it's automation of exploratory data analysis, it's integration with Jupyter Notebook environment for model development and model experiments, it's KPI validation, so it's alarming when we have a drift in data or in the target feature that can be referred to the model drift. It's parameter testing that ensures the data format consistency for the new data streams, and it's champion challenger tests. And now I'm going to pass to Mehmet to talk about Pentaho.
Thank you, Anna. Now, in the next part of the presentation, I will talk about the Tüpraş Pentaho experience. And can you pass the second one? So first of all, if we talk about Tüpraş, we are a company about a 4-year historic technical expertise in analytical science and also making development in data analytics in 3 different locations. These locations are İTÜ, METÜ, and Kocaeli. While making all this investment, our biggest goal is to continue making data-driven decisions as an analytical company. And next one. And one of the steps we took to achieve these goals was to start using Pentaho. With Pentaho, approximately totally in our refineries, about 600 million lines of data produced per day were made accessible easily to everyone. And also, this is the important thing. Another important thing is the digitalization projects were carried out independent of IT. So we try to extend this to each unit, each department by increasing our analytical competencies, and we try to make this situation sustainable. This is another important thing. So after fulfilling all these needs, we see that more than 40 users and more than 200 individual projects have been realized today. So next one is other contribution of Pentaho to us have increased the importance of data with the availability of data. So by using data, projects in different subjects, such as, for example, predictive maintenance have increased. So predictive maintenance cases is also important thing is refineries all around the world. So while doing this project, statistical languages such as R or Python, Zeka started to be used. The users demand this programming languages to use on Pentaho also. So in many departments and data citizens have started to grow, and the projects produced have turned into value and saving by the users. This is another important thing for all the companies, I think. And now I will briefly talk about the projects. Can you pass the next? Talk about the projects we have done using Pentaho and some other platforms. First one is the hydrogen network optimization. For this project, the aim of us is to ensure that the kind of product, HRG product, is used optimally in some units, plants, during the production. So with this optimization, hydrogen units started to produce at the most affordable price. So previously, this decision was made with operator decisions. This is really development things in refinery. So at this stage, the result obtained by working a linear optimization model that works every hour are applied in the unit. The Pentaho provide this scheduler things for us. So another project is Bitumen penetration prediction. As you can see, there's lots of things on the screen. So this is a little bit more complicated. So you can think of this bitumen product as a asphalt. Asphalt means on the way, in fact, everybody knows, but we called this product bitumen. So the aim of this project is to estimate the bitumen quality using the proportion of process oil and sensor data. The estimation of bitumen were completed by using process and laboratory data with a regression approach. With this project, the increasing bitumen demands were fulfilled better, and the amount of different products spent for quality improvement was safe also. And in short, then the next one is a kind of architecture for these two projects, and also the general architecture for the Pentaho sites for our company. Some of our main data, maybe I can give some information. For example, the PhD is the classical DCS system on our refinery and all other refineries. So this is the distributed control system, and we can get the data from PhD, LIMS, kind of the laboratory databases, and some local databases that we use. And this is the important things. Another important things is the users can log the model results to local DB, and then can use this data from another application if they want. So, and another important thing is these data sources work in integration with Pentaho server, allowing users to develop analytical models on this platform. And also the other part is the Carta part. Carta can create an API to transfer these model results to different platforms, and you can use this developed models from another application with the API. So apart from this, we continue to develop projects in many areas, in finance, planning, and process safety maybe. While realizing this project, we are trying to take advantage of the innovative platforms like Pentaho. So finally, on the business analytics side, of Pentaho, many of our works using C2's platform. This is another platform on Pentaho. It comes from Pentaho, and we complicated a lot of projects, and we going on. As you can see, this non-IT teams completed and commissioned all these works you see. This is the important things, because we have a lot of chemical engineers especially, and we have a lot of engineers in refineries. So we will continue to work to create higher added value with Pentaho, of course, and in analytical cases in our refinery. So thanks for listening. And with Anna, we will happy to answer any question you may have.